This is a joint work with Ming Lee, Sebastian Shelter, and Martin Drake. Okay, so let me start with introducing what I want to talk about. First, what is within basket recommendation? Here, we define the recommendation scenario higher. Okay, thanks. As that we have a user, and for this user we have a history in shape of a sequence of previous baskets. So each basket is represented as a set of items that they have previously purchased in a single transaction. And also this user has a current basket in form of an ongoing session or an ongoing shopping journey. And the goal of the recommendation system is to recommend items for this incomplete ongoing or current basket. This task is related to more widely studied or more popular recommendation tasks such as session-based recommendation. The difference with session-based recommendation is that there it's usually assumed that we don't have any information about the user's past session, so there's only an ongoing session that the recommendation needs to recommend items for. And there's also next basket recommendation, which is similar to this one. The difference here is that we don't have any information for the user's current basket, so only the history is given, and the goal is to recommend a complete list of items for the next basket. Another related task is what is called personalized session-based or session-aware recommendation, where it's completely similar or exactly similar in terms of what we have in input and output. But the difference is this task is usually studied in other domains, so not in grocery shopping. And studies on grocery shopping have shown that this domain has very particular characteristics, such as, like, the most important one is that users or customers tend to repurchase stuff. So they have repeat items in their transactions where they repeatedly and regularly buy. As I mentioned, the personalized session-based recommendation is very similar to the task that we have, and there the state of the art is considered to be like graph neural network. So this is a picture from a paper accepted at Wisdom last year, which the way that it works is that it first uses a graph neural network model and trains it on a graph that is constructed based on previous sessions of the users, and then combines this learned representations from this graph with the current session information and provides recommendations. Now, despite the fact that neural networks and graph neural networks are very popular in the literature, recent studies have also shown that neighborhood-based model could be more effective or comparable to the state-of-the-art neural basket or session representation learning models. And these have been shown in session-based recommendation and next basket recommendation. Now, our motivation or question here was that can we define an effective neighborhood-based model for within basket recommendation as well? So here I will introduce our model, which we call PERNIR. Again, to recap, the goal of this system is to assign a score or relevance score or recommendation score to the items in the catalog, except the ones that are currently in the user's basket, given a user and the history of this user and the current basket that this user has. Now, the way that we do it is that we define PERNIR with two different components. One is the personal component, and the other one is the neighborhood-based component. And the reason that we basically divide this into two parts is the importance of personal history and personal information in grocery shopping. And I will continue with going over these different components. So the intuition about this the way that we define pernure is that the score of an item can be computed basically based on how this user has consumed the item in the past and how the neighbors of these users have interacted with this item in the past. So to do this, we define a linear combination of two a scoring function. One is the personal one, and the other one is the neighborhood-based one. And we combine these two scores to achieve the final recommendation score for a candidate item given a user and the current basket. The way that the personal scoring function works is based on, again, an intuition that we have. We want to capture both the short-term interest of the user and also the long-term interest of these users. We assume that these long-term interests are kind of captured in the way that the user has interacted with this item in the past in their history, and the short-term interest is also shown in the current basket, in the items that are currently in the incomplete basket. And we define this personal score function based on this using two different components. One is the history-based to capture the long-term interests, and the basket-based scoring function that captures the short-term interests. Another component of the model is a neighborhood-based scoring function. Here, our goal is to capture the collaborative information in the way that users behave in our setting. The way that this scoring function works is that we assume that for a given item, a candidate item, the score of this neighborhood-based scoring function is a kind of a weighted average over how the users, the neighbors of our target user will kind of act or compute the personal score for this item given the current basket for the target item. So if we have a set of neighbors for a user, and assuming that each of these neighbors were given this current basket, how they would have personally scored these items. And then this weighted average is for the weight we use the similarity between users. And with that, the recommendation model is complete, and we have the scores for all the items. Now I will go through the experiments that we conducted. The way that we evaluated the recommendation performance in this scenario is in a next item prediction scenario. So the metrics that we looked at are standard ranking metrics like MRR and hit rate at two different thresholds of K for 10 and 20. We also use two data sets. So one is publicly available. It's called Instacart. We used a sample of 30K users with around 400K baskets. And the other one, X Online, is a private data set with a lower number of users and baskets. So first, we evaluated the performance of the recommendation system in general, and we compared our method with a lot of baselines in for different tasks, like session-based, next basket, or personal session-based. We observed that our model provides a state-of-the-art performance and outperforms all of the baseline for all of the metrics and data sets with significant margins of up to 12%. We also find out that the next best performance comes from the next basket recommendation models, which are designed for the grocery shopping scenario and not from for example, the personalized session-based recommendation models. And here, specifically, we observed that the state-of-the-art GNN-based model performs poorly on these data sets. We also conducted an ablation study and looked at the effect of the different components in our model. We observed that to achieve the best performance, we need to have all the components together. So we removed each one of them, and we saw degradation in the performance. We also saw that the importance of the personal scoring function, which captures the user's history, basically, is higher than the rest of the components in both of the data sets. At the same time, we also saw that the effects of And the other components like basket-based scoring function and neighborhood-based scoring function is different across two different data sets. So for example, in X Online, our private data set, these two components had a higher effect in terms of performance. And this also relates to the fact that these data sets are different, for example, in terms of average number of items that are in a basket. We also went beyond like only look at the average recommendation performance and considered the performance at different with respect to different aspects. Here, this figure shows the performance in terms of hit rate at 20, which is the blue line, and the x-axis shows the length of the current basket, so how many items are in the current basket. And the red bars here show the distribution of the current basket length in our X Online dataset. What we see here is that the performance correlates negatively with the basket length. So basically, the smaller is the basket, the recommendation performance is higher. And this means that like predicting the next items, when there's not still a lot of items in the basket, so you can say that the most obvious items is easier for the model. We also looked at the user basket, the relation between the recommendation performance and the length of user history. So basically the number of baskets in the history. Our question here was that when the system knows more about the users and there are more baskets in the history, what will happen to the performance? Here again, the blue line shows the performance in shape of in terms of hit rate at 20, and the x-axis shows the number of baskets in a user history. We observed that here we have a positive correlation, so the more users interact with the system and add more data to it, the performance increases. Another thing that we looked at, and here it's also a bit more maybe specific to the domain of grocery shopping, is the performance for different types of items. So assuming that this next item that we want to predict is an item that is previously purchased by the user, aka it's a repeat item, or if it's a new item, so it's an item that this user has not previously purchased. Here, this figure shows again the hit rate at the y-axis, and the x-axis shows how many items, like the cutoff point of the number of items that we are considering for the hit rate. And what we see here is that, like for the repeat items, like with the cutoff point of 200, we are already achieving the highest performance in terms of hit rate. However, this is very different for new items or unseen items, which means that it's more challenging for this model to predict unseen items for the users. And with that, I'm going to conclude the talk. So here in this work, we proposed Pioneer, a personalized neighborhood-based model for within basket recommendation in grocery shopping. And through extensive experiments, we studied the contribution of different components in our model. There are also a few directions that we would like to consider for the future work. One is that we looked at like the personal session-based models in grocery shopping and saw that they don't perform very well, but the reverse question remains unexplored. So whether this model that we designed for this domain will it work for personalized session-based models in other domains. And there is also a large room for improvements in terms of recommending new items, which can be in this model can be achieved by improving the neighborhood-based neighborhood-based scoring function, which is kind of responsible for capturing these items. And yeah, this is it. Thank you.